Hello, guys. So, as promised, I do have a review or a review key for you guys for your upcoming test on momentum and impulse. But I do want to take some time and I want to go through this the old-fashioned way with the old board and you guys watching along with me. So, let's start to take a look at these review questions that I've given out to you guys. So, number one, make sure to have a working knowledge of momentum and impulse. Well, you know what momentum and impulse are. We'll move back here. You know what momentum and impulse are, right? Uh, Momentum is P equals mv. It's how hard it is to stop a object moving, okay? Impulse is the change in momentum, but it's also the force of an object times multiplied by the time. Bring this up just a hair. There we go. So it's the force of the object multiplied by the time. So have an understanding of how these are related, how impulse is actually made up of momentum, and specifically, it is the change in velocity, and we know that's final minus initial, okay? Number two, we're going to bring it all the way over here. Number two, right underneath my name, Mr. Fabianski. Number two, relationship between mass velocity with regard to momentum. So we know that P equals mv. Think about this. If you have object one and object number two, okay? Both have the same momentum. But this object has a big mass, and this object has a little mass, kind of like the car and the fly. Well, the car, to have the same momentum as the fly, is going to be moving very slow. For the fly to have the same momentum as the car, he's going to have to be moving very fast. So think of this like a seesaw, okay? If the momentums are the same, if you have a big mass, you have to have a little velocity. If you have a little mass, you have to have a big velocity. They have to equal out in some way, okay? Number three, relationship between force time with regard to impulse. So now we know impulse, J equals force times time. It's the same idea, okay? If we have two objects, number one and number two, and they have the same J, well, if this guy has a big force and this one has a little force, this one needs to have a little time and that one needs to have a big time, okay? It's the seesaw pattern again. In order to have the same impulse, we need to alternate their times and their forces. So think about it. If an egg were to have the same impulse as a bowling ball, the egg would need to travel at, have a contact time that is longer because it brings such a small force. Then the bowling ball, which brings a larger force, its contact time would only be very small to get the same impulse. All right. Number four. Let's see. Be able to solve conservation momentum problems. Oh, stick together and don't stick together. So those are our equations, right? And you guys will have the equations, I promise you. Let's see. So we have stick together and don't stick together. Let's do the don't stick together first. That's m1v1 plus m2v2 equals m1v1 plus m2v2. All right. How many objects do you have to begin with? Two. How many do you end with? Two. We're using this equation. Now, if you have two objects to begin with, but only one object to end with because they've stuck together, like maybe two cars crash and they stick together, then it's going to be our velocity, m1 plus m2. All right? Two objects to begin with, one object to end with. Now remember, this one can go back and forth as well, right? So say you have I don't know, like a water gun, right? So the water and the plastic squirt, plastic water gun are one object to begin with, and then when they shoot, the water is one object, and the little plastic squirt gun is a second object. Okay, so remember, that can go back and forth. All right, let's see. So I am going to, well, let's continue on. Let's get the first page though. Everybody good? Can I erase this? I hope so, because you guys could just stop these videos. So let's erase this. And let's move on to complete the first page, and that'll be it for this video. Oh, just so you guys know, cardigan, you can't really see it, but cardigan, still gotta rock the cardigan even when you're at home. Number 5. All right, our first word problem. Compare a bullet and a ping pong ball traveling at the same speed. All right, so we have a bullet and a ping pong ball, and they're both traveling at the same speed. The bullet hits the wall and slides down the wall. The ping pong ball hits the wall and bounces back. So here is the wall. The bullet hits and like smudges up and then just slides down. The ping pong ball hits, rebounds, and comes back. Okay, very, very interesting here, right? I don't know about you, but I'd rather be hit with a ping pong ball. All right, this guy can do some damage. So, but wait for the question, see what it asks. Which has a greater change in velocity and which one has a greater impulse? Now, this is just like that handout that we did before. It's asking the same question, just in different ways. Which has a greater change in velocity and which one has a greater impulse? Well, remember, impulse equals the change in momentum, which equals m times the change in v. So I know you beat me to it. I know you're screaming at the computer screen right now, Mr. F, Mr. F, they're the same thing. I'm like, I know. But just in case you didn't get it, right? Whichever one has the greater change in velocity has the greater change in momentum, has the greater impulse. So if you figure out which one has the greater change in velocity, it's the same one. Let's take a look at this. This velocity, let's say, goes from, I don't know, 200 meters per second down to what? 0. You're right. 0 meters per second. Let's say, now does it say they're traveling at the same speed? They are. So this one is traveling at 200 meters per second. Let's just pause and think about that. A ping pong ball traveling at 200 meters per second. Sorry, I need like one of the little light things above me. I haven't figured out how to do that on YouTube, but I'm sure I will get plenty of practice. So this was traveling at 200 meters per second. It's going to bounce, a rebound, and come back at, does it say? Bounces back, let's just say it bounces back at 100 meters per second. Which one had the greater change in velocity? Think of it as a number line. This one went from 200 to 0, so that's a change of 200. This one went from 200 to 0 to 100. That's an overall change of 300. So the ping pong ball actually had a greater change in velocity. And you know what? I don't care. You could have just said it was bounced back at 1 meter per second. It would have been 201. It still would have had a greater change in velocity. So the ping pong ball has a greater change of velocity. Let me get a different color here just to make sure you guys get this. The ping pong ball, let's see. Ping pong ball had a greater change in velocity and it also had a greater impulse because remember, they are the same thing. Okay? If you're getting this, excellent job, guys. If you're not, if you're still having a little difficulty, that's all right. We'll get through this. Make sure you email me with any questions, okay? Or join those Zoom chats that we do daily. And number 6, we're going to finish this video out with number 6. Let me just erase this. All right. Number 6, a 2-kilogram ball. Ooh, this is A, B, and C. So let's get this stuff written down. A 2-kilogram ball is rolling at 10 meters per second towards an 8-kilogram ball at rest. I think I know what type of problem this is. Solve for the velocity if the two were to stick together. So how many objects to begin with? 2, very good. So 2 objects to begin with. They're going to hit. How many objects to end with? Wait, what was that, guys? I couldn't hear. 1, very good. 1 to end with. Which problem is that? Or which equation? Good job. M1 V1 plus M2 V2 equals V M1 plus M2. Doesn't matter which object is which, as long as we keep it consistent. So let's say the 2-kilogram ball is moving at 10 meters per second. So 2 kilograms times 10 meters per second plus the second bowling ball is 8 kilograms, but it is at rest. What does rest mean for a velocity? Hand raise, hand, yes, you. Perfect. 0 equals our velocity, which is what we're looking for. It specifically asks, solve for the velocity. And then we just add our masses, 2 plus 8. Let's do this math out. 20 plus 0 equals V times 10. What do we do next? Very good, divide. So we get a velocity that is equal to 2 meters per second. And that's for A. Very good. I'm gonna leave this up here so that we can compare. Let's look at B. All right, so I'm gonna come down here. Let's do this. B, all right. Solve for the velocity of the 8-kilogram ball if the 2-kilogram ball continues to move at 1 meter per second in the same direction. All right, so how many objects to begin with? 2, very good. There's a collision. How many objects to end with? 2, you're right, good job. Because they're not sticking together now, they're hitting and bouncing off. So M1 V1 plus M2 V2 equals M1 V1 plus M2 V2. Let's begin to fill this stuff in. Solve for the velocity of the 8-kilogram ball if the 2-kilogram ball continues. Okay, so to begin with, it's the same beginning. The 2-kilogram ball is moving at 10. The 8-kilogram ball is not moving. The 2-kilogram ball will continue to move forward at 1. It's moving in the same direction, very important. So our signs are the same. We're going to come back to this when we do the next one. We want to find the velocity of the 8-kilogram ball. This is what we're looking for. All right, let's do the math out. 20 plus 0 equals 2 plus 8V. 20 equals 2 plus 8V minus the 2 first, guys. 18 equals 8V. And then we simply just divide and we get a velocity as equaling. Can you still see that? Yes, it's right at the very bottom of the screen. 18 divided by 8. Take out your handy dandy calculator. You get 2.25. 2.25 meters per second. Did I forget? Nope, I didn't forget a unit. Don't forget your units. Serious. All right. Questions so far? I'll move out of your way. Questions at all? Questions at all? All right, guys, one more for this video. Let's take a look at C. So C says, solve for the velocity of the 8-kilogram ball, blah, 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 if the 2-kilogram ball continues to move at 1 meter per second in the opposite direction. So things are going to change now a little bit. All right, let's try this one out now. So how many objects to begin with? You're right, 2. So we're going to put C here. 2 objects to begin with. There's a collision. How many objects to end with? 2. Very good. So M1 V1 plus M2 V2 equals M1 V1 plus M2 V2. Okay, guys. Let's plug in our numbers. Let's see. 2. We're starting off the same way again. Plus 8 times 0, right? Equals 2. Now, which way is that 2 kilogram ball moving off? If we read again, it's moving off at 1 in the opposite direction. Opposite, we have to watch our sign. -1. Right there, that's going to make the difference. Opposite direction, it's negative. Plus 8 times V, that's what we're looking for again. And let's see how 1 in the normal direction will change the answer to 1 in the negative direction. 20 plus 0 equals -2 plus 8V. 20 equals -2 plus 8V. What do? Very good, class. We're going to add that too. So we have 22 equals 8V. We divide by the 8, and we get I'm going to put it over here, a velocity that's equaling, let's see, 22 divided by 8, 2.75 meters per second. So we could see that by having the ball move off in the same direction, we get a velocity of 2.25. And we can see that more energy was transferred when the ball actually bounced back. It's 2.75 meters per second. Okay, so I hope this has helped you to understand a little bit with regard to this math. I will be putting out another video for the second part of this, maybe even 2 videos, we'll see, depending on how it goes. But please email me, guys, if you have any questions. Go through this as many times as you need, and we're looking at a test next week. All right, guys, take care. I'll see you guys in the next video.